Hi, everybody. Alan Lipscomb with Nortec Global HVAC. I appreciate you joining me today. Our agenda today, we're going to go over setting up airflow on our air handlers. I get a lot of questions on this, so I want to try to break it down and explain it in a way that hopefully that at the end of this presentation, you're a lot more comfortable with what we're doing. So we're going to talk about finding the airflow requirements, where you would find those for a specific system. We're going to go through and demonstrate how to set the speed on different air handlers. They are not factory set. When they ship, the air handlers ship at low speed. We don't know the application they're going in, so the installer is always going to have to adjust the air speed on any installation that they do that's common throughout the industry. I want to remind everybody that air is the first word in air conditioning. If we don't have the correct amount of air going across a coil or a heat exchanger, they are not going to perform as designed, and they could create trouble, cause problems, inefficiencies. And additionally to that, ABCs, airflow before charge. If we don't have air going across a coil or a heat exchanger, we could have problems that are going to result in customers calling in for service, water overflowing, a number of reasons that you'll run into. One of the things I wanted to point out on our older QRD, if you look at this QRD, you'll see there's a few matches that have that shaded background to them. So we've got quite a few examples here. The shaded background would be your indicator on that particular matchup that you would need to change the piston in an outdoor unit. I would also like to point out, like on this 2-ton match here, for example, or the 2.5-ton, at startup, you had to add quite a bit of refrigerant to these systems, these legacy systems, on the systems where your line set was within 15 feet. The reason I'm saying that is because as we have evolved, we're adding more refrigerant and we're making less changes on metering devices. So this is the current one. If you'll notice those two matches, as long as you're within 15 feet, you don't have to add any refrigerant on these, as well as some of the airflow requirements have changed as well. So for this example, we're going to be walking through with a 2.5-ton split heat pump system. Our selection is going to be with the B6 BMMO 30KA air handler. And what I want to know is, I want to know what my CFM needs to be for this. So where I find the two come together at this intersection, it tells me right here, for this system to work properly, I need to provide 930 CFM of air across that coil. So in order to do that, the next step is we're going to have to go and we're going to have to look at the installation instructions that come with the air handler. Now, one component that we don't know is what this external static pressure is of the duct system that is already in this house. The only one that would know that would be the contractor. There's no way that you could tell them what it would be. They would have to be able to go out there and measure it. And once they knew what that external static pressure was on that system, then they could make the adjustments. So we're going to look at the performance data for the air handler. And just for the sake of the conversation, we're going to be working with a external static pressure of 0.50. So the contractor has said, okay, I've measured it, it's a 0.50. How do I set up the airflow on this air handler? So out of the box, this unit will produce at 0.5 static. Right, here's my 0.5 static. Here's the air handler that we're working with. Out of the box, it will produce only 704 CFM, which is short of the 930. So again, airflow before charge. Can we get to the 930? Yes, we can. If you look right below it, if we move that motor tap, it comes from the factory set at low. If we move the motor tap to medium, we'll be able to deliver 940 CFM across that coil, close enough nominally for the 930. If he's got it charged right, he's going to have a system that's going to provide the efficiency and the capacity that he sold the customer. How do you make the change? What does he actually have to do to make that change? Kind of simple. He goes to the motor itself. The motor is going to have two wires that come together. It's going to come plugged into the number 6 terminal. He wants to move it to the number 5 terminal. That will increase the speed of that motor and will allow him to get the CFM that he needs. Simple as that. So we also have air handlers with ECM motors. ECM motors and the variable speed motors are different because they're multi-speed motors and they're controlled by a series of dip switches on a board. So we would start the process the same as before. We'd go back to the QRD. We'd find out what is the required CFM for the matchup, and then we would continue on to the installation instructions of the B6EM, which is the ECM motor. The switch settings are going to be based off the cabinet width. So we have an A cabinet, we have a B cabinet, and we have a C cabinet. Again, the contractor would need to know the static of the system. Switches 1 through 4, so there's a total series of 8 switches. Switches 1 through 4, they're 2-position switches, on or off. They control the speed when it's in the heating mode. Switches 5 through 8 control the speed in the cooling mode. Anytime that you make a change when you're setting the system up, if the power has already been turned on to the air handler, it needs to be turned off after the changes are made. When power is returned to it, then the motor will reprogram. So looking at the airflow settings, we're going to go with some of the same numbers. So again, we're looking at just an A cabinet, and let's say that just for the conversation, we're going to still be looking for 930 CFM. So we've got a pretty busy chart here, if you will, so I'm going to try to simplify it a little bit. So this is our A cabinet. We're looking for 930 CFM. For the sake of the conversation, we're going to stick with a 0.5 static. So you see my 0.5 static up here at the top here. So I want to come down that column, and I want to look to see how close I can get to 930. Well, I can get to 910 CFM. That's nominally, that's a great number. It doesn't have to be right on the number. How do I make those changes? What's my next step? I can hit the 910, but how do I do it? Well, I simply come across here. As I come across here, this is the indicator of how I change the dip switches. So I have a series of 8 dip switches that can either be set to on or off. So for the 910 CFM at a 0.5 static, I'm going to set switches number 1 and 5 into the on position, switches 2 and 6 into the off position, switches 3 and 7 into the on position, and switches 4 and 8 to the off position. And this is what the switches look like. So 1 through 8, they're labeled heat and cool, and they're labeled off and on. So with a small screwdriver, all you have to do is go in, match these settings. So this is switches 1 and 5, 2 and 6, 3 and 7, 4 and 8. And that's how they set the airflow up for the B6EM air handler. It's as simple as that. Now with the B cabinet and the C cabinet, it's the same process. It looks identical, the same. So we're going to move on to the B6VM, the variable speed motor. So again, you're going to already have to know what's the CFM based off the QRD. Again, the switch settings are going to be based off of your cabinet width, A, B, C, or A, B, or C. Contractor needs to know the system static. Switches 1 through 4 control speed and heating, 5 through 8 in cooling. Change setting with the power disconnected or cycle the power after making changes. So we're gonna stick with the same example again. We're gonna shoot for 930 CFM. So we're working with the A cabinet. So A cabinet, if we need to hit 930 CFM, we're gonna set our switches again for cooling 5, 6, 7, and 8. So 5 is gonna be on, 6 off, 7 on, 8 off. And for heating on the A cabinet, switches 1 through 4 just need to all be set to 0 because based off of what size heater he plugs into it, it will set the airflow based off of the supplementary heat that's installed. Same way with the B cabinet and the C cabinet, works the same exact way. So if we were shooting for 930 on the B cabinet, you can see here we have 950. So switches 5, 6, 7, 8, on, off, off, on. We would need to have the switches 1 through 4 set to 1, and it would pick up on the heater that was installed. C cabinet works the same way. The only difference is it doesn't matter which way switches 1 through 4 are set. but they all have to be set either on or off. It's as simple as that. One thing that you may or may not have noticed on the variable speed, there is no notation of a specific external static pressure, because the variable speed will try to ramp up and it'll run to the CFM that you set it to run at. If you put a variable speed air handler on a inefficient duct system that has a high static, it will try to defeat that up until a point. The problem with that is it's not the right thing to do, so they need to make sure that they have a very low static system should they want to put a variable speed system on an existing ductwork. So I appreciate your time. I hope you found this valuable. If there's any questions, again, Alan Lipscomb, Nortec Global HVAC, please reach out to me, let me know. I'm certainly open for suggestions on topics and would be glad to help you out in any way I can. Stay safe out there. Have a great day. Certainly appreciate your time. Thank you.